All right, let's continue. So it's 16 square, one less, and which means what's the final answer here?
FF.
FF. That's really good. That's the correct answer. Because it's if you go one more, this becomes the
100.
Yeah, that's the 100 hex. The minus 1 equals FF. So that's just some quick. This probably don't really need a lot of time. Now the next one is to convert decimal numeral 65 to base 16 and base 3. Okay, let's give a little thought in there. So due to time limit, I only want to hear any thought at this point. If you have any thoughts, speak it up. Anyone?
So for base 16, you would have 2 digits, and it would be 16 times 4, which is 64, and it's 1. 64 and 1. So 4 and 1.
Mm-hmm. 41.
Yeah.
Mm-hmm. What about base 3?
And for base 3, it would be 3 digits. And 27 would be 2. The first digit would be 2. And then 1 and then 2. 2, 1, 2.
Anyone else? Okay, that's close, but not quite. So I'm going to look at here. So 65, what Sarah said is right for the 16. What we want to know is how many 16 or 16 square does a number have? In this case, we don't have 16 square, it's just 16, right? So that's the 10th digit. And exactly that's the 10th digit times 4. That would give me the closest 10th digit number. And we have 1 left, so it's 41 in the 16 base. And for the 3, that's correct. We look at first. We look at 3 to the 3rd, right? That's the 27. Because 3 to the 4th would be 81. That's too big. So 3 to the 3rd will be some things we're looking at. So once we have 3 to the 3rd, we can have 2 of them, right? And so I think this is a little, yeah. 2 to the 3rd. We can have 2. And once we have 3 to the square, we have only 1 in there. And that's 9, right? And then thing here is we don't have 3 to the 1st. Okay, this is a 0. But we do have 2 left. Therefore, we have a 2102 as base 3. So when Sarah said this, she missed this digit here. Okay. All right, I'm going pretty fast, so please do review offline. And still one more, actually one more, I'll just go over this. So the base 3 representation of X is this guy, all right? Now find the first digit on the left of the base 9 representation of it. Okay, this is base 3. We want to find base 9. Now, what's the relation between base 3 and base 9? So can you think about if we have a base 10, now we're looking at base 100, what would that be? Then it will be easier, okay? So from 3 to 9, because 9 is 3 to square, right? And all we should do is to group them into 2, okay? It's just going to be grouped by 2 from the right side. And then we keep doing that. And what we find is 12, okay? So 12 will be the base 9 most significant bit. And that 12 will mean 1 times 3 plus 2 equals 5. All right, so this is the answer. Now, what I just mentioned, think about from base 10 to base 100. 100 is just 10 to the square, right? So 5327 in base 10 is 5327. Now, in base 100, it simply becomes 5327. And 53 is basically the 10th digit, and 27 is the unit digit. Okay, you just group them together. Very similar, you know, from base 2 to base 16, we just basically group 4 digits together to get from base 2 to base 16. For example, if this is my base 2, and then I group them every 4, that's this 2. And then this would be the my 10th digit of the 16 base, and this will be a unit digit. And in this case, this is 6, and this is B, okay? So this is just quick conversion between the two. All right. Okay, because the importance of this is not significant, I went really fast. Please review offline. If you can't get it at all, don't worry. It's not something we have to grasp at right now, but give it time when we meet problems, you know, more, how to say, we'll see a problem and then we'll get along, and we'll go over them again, okay? Okay, so the next thing I want to talk about is a logarithm. So logarithm is the opposite of exponent. Basically, if you have a to the order of b, power of b equals c, then the b, the power part, is equals to log with a on the base and c. So this is just how we do the logarithm. So we'll be looking at the power term, okay? As example, so 10 in the power of x equals 1, 2, 3, 4, then we can write x equals log with 10 base 1, 2, 3, 4, okay? Sometimes we just simplify log 10 into just log, because log 10, right? Log 10, we just say, okay, if you see log, just log, no base, that's log 10, all right? There's some property here, log, anything if base and the top is the same, then it's 1. That's pretty straightforward, right? Because a, the power of 1 equals a, okay? This is how you kind of analyze the logarithm. And anything with 1, log 1 equals 0, because anything the power of 0 equals 1, okay? And if you have a with base and then a to the power of x, basically it's x, okay? X equals that, because a the power of x equals a in the power of x. Okay, makes sense? So next, we're gonna introduce the property here, 10 to the x, 10 to the y, just example, equals 10, x plus y, we all know this. And x plus y equals log 10x, 10y, okay? Now, because we know x equals log 10x, y equals log 10y, therefore, we can write log 10x times 10y equals log 10x plus log 10y. Okay, so in general, log a multiple equals log a, separate them with a sum. So this is a very important feature. And I summarize all the useful property of log. And one other thing that this doesn't have is when you revert the base and top number, you just basically inverse them. So make 1 over log b over a. Log a b equals 1 over log b a. Okay. Now you might want to take a screenshot. So these are really useful, especially the first three. Anything about exponents on the top can be put in the front, make it multiplication. Okay, and we just went over this. So when the base is equal, when you make a sum of the two equals the same base and multiply the two. All right. From 2 to 3, it's pretty straightforward because minus sign can be translated to c to the power of -1, which is 1 over c. Okay. So basically, you're multiplying log ab plus log a 1 over c. Right. That's just b times 1 over c, b over c. Okay. Okay. So far, any question? This is more like a review. I assume the logarithm is already mentioned in most of the class. And hopefully you're not the first time you're seeing it. Okay, let's quickly do a problem, 2 minutes. See if you can get this challenging one. Okay, I'm just showing in here, there is some formula you might want to note. I'll come back. Anyone has any thought or the first step, anything that can help? No? Yeah, to do this kind of thing, we will first apply log on both sides. I bet a lot of people don't think about this because we have a power in here and we have a bunch of power and combinations. So we should apply the log on both sides. So on the left, we got log this whole thing. And look at this. So this is log x, right? When you have a log, and then we have x to the power, and this power can be brought to the front, right? To become a log, to become a multiplication. So this becomes log x times log x equals log x squared. This is the left side. And on the right side, we do a log. Okay, so I'm just gonna take a step back. So remember, this is the first formula. When you have an exponent or you have a power, this power can be brought to the front and to make a multiplication. Okay, this is what we just used. This whole power is brought back to become a multiplication that makes log x squared. Okay, the whole thing is doing the square. All right. Now on the right side, we're applying log on this term. And remember this, we have this, right? So this formula, we have b over c equals log a b minus log a c. Okay, this is just reverse of this property. And basically we got log x third minus log 100. Okay, now further, this is the power, right? This exponent can be brought to the front. That becomes 3 log x. And then log 100 is actually 2, right? Because this is 10 to the power of 2 equals 100. So then we have a quadratic equation here. So log x squared equals 3 log x minus 2. And make log x your variable, right? And you get log x equals to 1 or 2, all right? When log x equals to 1, you got x equals to 10. If it's 2, then you got x equals to 100. Okay, make sense? Questions?
Why can x be 100?
It can. 100 is a valid answer. So if you look at here, log x, when x is 100, this is 2, right? This become 100 squared. And then this is 100 third over 100, sorry, 100 third divided by 100, become 100 squared. Yeah, x can be either 10 or 100. If it's 10, log x equals 1. If it's 100, log x equals to 2, right? Okay, let's move on. Let's do a simplify. This is probably a little bit easier. We have this 3 sum of log 3x. Can you simplify them? They're all inverse. Okay, 1 minute. Let's move on back to the property. Maybe you can take a look which one that's usable. Take a snapshot if you need. Okay, I'm going back to the problem. Okay, any thoughts? Anyone?
You can use the inverse thing and make it log x3 plus log x4 plus log x5.
Mm-hmm.
And using the addition property thingy,
Mm-hmm.
you can do log x 3 times 4 times 5. And you get log x 60.
Perfect. Yeah. So just to get back to what Sarah just said, so log like A and B, when you do the inverse, it become 1 over, right? So in here, the base is different, so you can't do anything easy. So if we put the x in the base, it basically become easy to calculate. So so 1 over log 3x become log x over 3. Okay. So and then because of the addition property, when you have same base, when you add them together, it's equal to multiply, use the same base, multiply the top value. Okay. Yeah, I think that's all I want to talk about the log. In a specific problem, if there is any interesting problem, we'll continue doing them. A little bit about ratio, as I promised, we should do a little bit on ratio. Okay. First is we have a property when A over B equals C over D, then any linear combination of them is still holding. So you can add any number of C. This doesn't have to be integer. Any number times C divided by B plus any number of D, and the ratio still hold. It's still A over B, still C over D. Okay. Example here is 3 over 6 equals 4 over 8, right? They're all 1 over 2. So then we can add any number, like I put 11 here, 3 plus 11 times 4 divided by 6 plus 11 times 8, and equals 47 over 94. So this is still 1 over 6, okay? Now let's look at this problem. So a lot of time we see problem that ask you to convert different unit. And for example, 1 inch is this much centimeter, and 1 ounce is this much gram, and convert this thing 16.2 inch square 1 over ounce to a unit with centimeter and gram. Okay, and to keep in mind that when we do the conversion, we can just do the unit. So the unit need to follow the same rule of number, okay? So specifically, 16.2 inch square 1 over ounce equals 16.2. Now we have inch square, and we know 1 inch is 2.54, and then therefore inch square become 2.54 centimeter times 2.54 centimeter. Everybody follows? So this is the inch. This is inch, because the inch means 1 inch, right? So 1 inch is this. 1 inch is this. That's the inch square, right? And then ounce, we just put 28.35 G, and the whole thing inverse. Okay. Because this is ounce, right? Ounce inverse. Now this becomes the whole thing inverse. Then we can just calculate this whole thing by multiplying these and then divided by this. Okay, we got 3.686 centimeters square 1 over gram. This is how you convert from one unit to the other. Question? There's really nothing fancy here. You just follow the same rule and do those units. Okay, that's the direct way of converting these. Okay, let's start with a problem. This should be really 1 minute. It's okay to have some thought. Okay, anyone?
14.5.
Yeah, 14.5.
Okay, who said that first? Can you go over it?
So what I did was I took 0.4536 kilograms and I converted that to pounds, which is basically the same thing. And so if I multiply kilograms to convert them into pounds, I have to multiply the millimeters to convert them from per kilogram to per pound. So I multiplied 32 milliliters by 0.4536 and I got 14.5.
Okay. Yeah, the calculation itself is not critical here, but yeah, the way of thought is good. This is Manit.
Yes.
Okay. Which group are you?
5.
5. Okay, thank you. Yeah, so the very first thing is because we want to do this conversion, right? Milliliter per kilogram. Now we don't know what kg equals what pounds equals 1 kg. So we have to do one conversion. We know 1 pound is this much kg, then therefore we just use kg equals 1 over this, we divided by this thing on both sides. And then it becomes so much, this much pound. Therefore, we convert the units exactly like what we did before. 32 milliliter per kg is milliliter per this thing, this whole thing we just calculated is equals 32 times this. And then the pound stays in the denominator, right? And milliliter stays in the numerator. So you calculate this times this equals 14.5. Okay, good job. Let's do one more. Let's do one more. 1 minute. Yeah, 1 minute is fair. Okay, this is pretty straightforward. Any volunteer?
Yeah, for A, it's 3 over 35. 3 to the 3 to 35. For every 35 animals, there are 3 cats.
How many cats are in store? 385.
No, I was answering the first question.
Oh, okay. What about the second one?
I got 3 to 32 for the first one.
But wouldn't it be all animals? Because it says the number of animals in the store. That would include the cats.
Yeah, 3 to 35.
Yeah, 35 is correct.
And then for B, there would be 11 cats.
Wait,
No, 33.
33 cats.
33 cats, sorry.
How do you get it?
385 divided by 35 equals 11 times 3.
Okay. Yeah. So this is what I just mentioned. So when you see ratio, you always just use a number, use a variable here. So they are 2m dogs, 3m cats, 30m mice. And then in this case, you don't even need to know the m, right? Just 3m over 35m equals 3 over 35. And in B, you do need to calculate m. So 35m equals 385. So m equals 11. And 3m is the cats. That's 33. Okay. Thank you for the participation. And next one. A minute and a half should be good enough. Hey, I need an equation. If you have an equation, you can start speaking. I don't need the final answer.
I think I got a answer.
Just a niche.
Yeah.
Go ahead.
Okay, so we added 4 marbles to the 2x. So, and then we had to multiply that by 2. So I have
The-
2 times 2x plus 4. And then since we're taking away 10 marbles from the 5x red marbles, because out of 5, we have the other side is 5x minus 10. When you simplify it, you get 18 equals x.
Okay,
So
hold on. What is your x?
x is 18.
No, what is your x as definition? So what do you assume? What quantity is x?
Okay, since it's because there's red marbles. So the ratio of the green marbles is 2x. Because
Okay.
it's 2/5. Because it's 2/5.
Sure. So green marble is 2x. What about red marble?
5x.
Is that right? It says the ratio
that's the total.
green to total is 2/5.
Oh, it's 3. Sorry.
Make a quick fix of your equation. So 2x is green, and what about the red? Anish, how many red are there?
3x.
3x. And then what's your equation look like?
Now it says 2 times 2x plus 4 is equal to 3x minus 10.
So you made adjustment. After adjustment, the green are twice of the marble.
Here should be on the other side.
That's right. But you're very close. Okay. So 2x plus 4 equals 2 multiplied by 3x minus 10. Okay, I use m, but it's the same thing. So 2m plus 4 equals 2 times 3m minus 10. And we can solve to get m equals 6. And total, we have 5m, so 30. Okay, that's pretty good. Close enough. All right, I think we have one more. Let's go.
Is it 7.5%?
No. But I like to see equation. If you have equation ready, let me know.
Yeah, I do have my process.
You want to talk about it? We got or anyone else?
Is it 3.5%?
No. What's your equation?
Well, I noticed that 6% of the 8th graders is in like 8th graders. There's like 1.5% more than 7th graders, so we can't really compare that. So we would have to put it into like the same category again as the 7th graders. So I did 0.06 divided by 1.5 and I got 4%. So 4% of the 8th graders and 3% of the 7th graders. Now we can compare that, and then I just took the mean.
Okay, yeah, that's incorrect.
Wait, so if you do if you replace 8th graders with 7th graders, you can do 6% of 1.5 S plus 3% of S is the total math count.
Mm-hmm.
Is it 4.8%?
Yeah. Yeah.
What's that?
Is it 4.8%?
4.8. Yes, that's correct.
Could I
Can I explain?
Yeah.
So I gave numbers like if there's 100 7th graders and there's 150 8th graders, and so 3% of the 7th graders, so it's 3 7th graders, and 6% of 150 would be
Yeah. So this is Ayushi, right?
yeah,
Okay. What's your group number?
4.